All right, so now we'll move on to the progress checks. All of these were labeled as Unit 5, but I do think that some of them were supposed to be Unit 6. So I'm going to go over all of them as if they were 5, and then go back and do two of them, 12 and 16. I think was supposed to be 6. So question number 4 is talking about hydrolysis and rate. Okay, so it says that the rate is directly proportional to the concentration of sucrose. So that probably means, it says under certain conditions, right? So that probably means that we're not going to have water in our rate law at all. It doesn't tell us what the exponent of the sucrose will be. It just, because it says under certain conditions. Okay, but if there's this direct relationship between sucrose and the rate, it probably doesn't include water. There's other things going on here too, like water is clearly in excess because the sucrose is in solution with water because it's AQ. The water doesn't have a concentration because it's just a liquid. There's a bunch of things that kind of point to it, but I think the telltale thing is that the rate is directly proportional to sucrose. You also notice that you can get rid of B and D right away. B says decreasing the temperature will increase the frequency of collisions. You know that doesn't make any sense. Decreasing the temperature decreases collisions. Decreasing the concentration of sucrose will increase the rate of hydrolysis by increasing the collisions. Makes no sense. So it's got to be either A or C. A says increasing the amount of water will increase the frequency of collisions. I don't think it will because it's pretty clear it's in excess. But even if that wasn't the case, we know that the rate is directly related to the concentration of sucrose. So we're going to pick C. Increasing the concentration of sucrose is going to change things because the rate is directly related to it. Even if it's not perfectly proportional, that's only under certain conditions, it is related to it. Question 9, the question that was posed on your document was, is this as easy, like how do you even start solving this problem? This is a very easy problem that they made very difficult. First order, straight lines, natural log, C. Now we are used to seeing ln of concentration, but it's really just amount. So concentration is more typical, but you also could use amount of moles, and that's fine. So it is, there was, the way the question was worded in the document was, is this just about reading first order in the question? The answer is yes. Yes, it is. All right, so question 12, which from unit 5, I don't think this is the one that we're actually asking about, but I'm going to do it anyway, because why not? Question 12 is pretty easy. All you have to do is find the rate law. And since the first step is the slow step, once I found the rate law, because it also asks for the overall equation, but if you look, all the rate laws are different. So I don't even need to do the overall equation, because I can automatically eliminate anything that doesn't have this as a rate law, so my only answer is B. If you wanted to do the overall equation too, which I don't recommend doing because that's a big waste of time, but you can while you're practicing. If you just want to practice, that's fine. So we have NO2, NO2, NO3, NO3, NO, NO. So we would get N2O5, two of them, 4NO2 plus O2. Yep, and that's what it is. So you can do that, but you don't have to. All right, so question 16 I also think was meant to be for progress check 6, but this is just a quick, obviously you're going to have a fastest rate when most of the more of the particles are going to be at the activation energy or higher. So if you look at the 4 different options, T4 has more of the particles at the activation energy or higher. So the answer is D. All right, so last one for project progress 5, and then I'll go back and do 12 and 16 from 6. So this one is interesting because the question here is what is folding? Folding isn't anything. What they're talking about here is if it's a 4-fold increase, it means you would multiply it by 4. If it's a 2-fold increase, that means you double it. 3-fold, triple it. 8-fold, multiply it by 8. They're just using terminology that you might not be familiar with. Okay, it's literally just saying 4-fold is 4 times. Okay, it increases by 4 times. So what you'll do here is write the rate law. We can get rid of A and B right away because they both talk about HI and we don't care about HI because the first step is the slow step. So now saying H2 and IBR are both doubled. So let's see what would happen to the rates if we doubled them. So if we started with it being 1, we would get 1K. If we had it being 2, we would get 4K. So that's going to be times 4. So the answer must be C. And if you want to check it and just do another one, I know some people might want to. Maybe we start with 2 and then go up to 4. So here we would have had 4K, and then here we would have had 16K, still multiplied by 4, which is just a 4-fold increase.